Well, good morning. Yeah, what I've decided to do is, since a number of people want to take the final on probably what's that going to be, Wednesday, rather than just do the review and then hand you the test, I think it's probably a little bit better practice to give you the review in advance. This doesn't mean that you need to take the test on Wednesday. Again, you'll have plenty of opportunities during the finals week. But for those of you who are going to do it, then I don't want to make it a big rush deal. So anyway, we will talk about learning curves and stuff like that on Wednesday, but that won't take too awful long. And then for those of you that are going to take the exam that day, good luck. But anyway, we'll do the review and get that kind of squared away right now. So the learning curve stuff we'll talk about. I'm just going to keep the lecture the same, so we'll talk more about it on Wednesday. Most of that is just common sense, and there's not going to be questions on the test regarding it. In terms of the test itself, same sort of format, more questions, because it is comprehensive, cumulative, whatever. So like 50-some questions. And some of them, are going to go back into the forecasting stuff like this. The number of periods and a simple moving average, the greater the responsiveness change. Obviously not. This only really works when you have a stable demand. That's a puppy in the background. Anyway, stable demand. So, bringing out a large number of periods can be good to capture that, but it also limits the responsiveness. If you have a trend established, moving average and even a weighted moving average isn't going to capture it as well as some sort of linear regression or other method. So the problems with the moving average, increasing the n, so that number down below the denominator. If you get out to 20, 30 periods, it's going to really decrease the sensitivity of it. Do not forecast trends well and requires historical data, which accurate historical data is the key. So garbage in, garbage out. Also, expect to be able to do a moving average. So this is just a straight moving average. Again, not too tough. The only thing to keep track of is that denominator on the bottom. That's where most people screw that one up. But multiple choice, there are no trick questions. So if you're not getting an answer, you got a problem. There's how to do a moving average, how moving averages work, and the sales and everything else. If you track it all historically, the moving average is going to be accurate, but it's going to be shifted to the side, so not shifted to the right. So not as useful as some of the other techniques. How to do a weighted moving average. And then, of course, everybody's favorite critical analysis type problems. So, again, this stuff's pretty important. This will probably be the last time you'll see this in terms of doing it, mechanically drawing it out. But if you can do it this way, then MS Project and everything else will be much easier, and you'll be able to understand it. So, again, first step is identify that critical path, and then start looking at the situations. And the only really important thing you got to look at on the situation is, whether that factor is on the critical path or not. So you'll look at that. Critical path's the longest path. Critical path's also the shortest time. So keep that straight. Any delay in the critical path, affects it. And critical path activities, by definition, have no slack time. So, these location decision type things, you got to figure out whether it's service retail or manufacturer or warehouse type thing. If it's service retail, it's going to be revenue driven. If it's manufacturing, warehouse, something like that, it's going to be cost driven. So, this one would be rather easy if you just look at the manufacturer there in the title and look for one with cost. Everything else is going to have revenue, environmental, all nice to haves, but cost is the driving factor in location for a manufacturer. And so again, those two items up there at the top, revenue versus cost. Tangibles, intangibles, again, those are The tangible are the ones that translate directly to a dollar value. The intangible future costs, yeah, if you've got union issues, if you've got, horrible education system, things like that, you might have other costs, but it's hard to put a dollar figure on them. But the other tangible costs are dead easy. More things, so regression models to develop, factor rating method. We will talk more about factor rating method in a bit, and factor rating method actually works well on either one. Break-even analysis for goods producing, because break-even analysis is related to costs. Service retail, you really don't care how much the rent is as long as there's a corresponding huge rent that translates to huge sales is a good deal. Cheap rent with no sales is not going to work in a service retail. People will not drive thousands of miles for a regular service type item. If you've got something like a chiropractic, a dentist, a barbershop, and those services are located closer, don't expect people to drive unless you've got some extreme competitive advantage, something to differentiate yourself, but really that would be tough to do. So here's a factor rating method. So again, these numbers are somewhat arbitrary, but it does force you to quantify. When you say, well, this place is better, that place is better, it forces you to actually delineate what's there, and maybe kind of weed out the more emotional decisions. But like I say, if you're ever presenting a proposal, factor rating method is the way you want to go, because again, it tailors it limits the discussion to the relevant items, and if people don't like your proposal, which is probably the most likely case until you identify exactly what they're looking for, well, that's what factor rating method will do. It'll give you the ability to identify what's going on. So pretty self-explanatory, not going to read that again. But again, those weights and the scores and all that kind of stuff, that's where the judgment comes in. Their notional example. But you end up having to do these things all the time, but they're actually, for that type of situation, they're the least painful. What is most likely to affect the location of manufacturing firm? Again, so getting redundant here, costs. Everything else, great. They may affect costs. They may have some, intangible effect on it, but things like competition in the area, you don't care. Actually, if you're manufacturing, you may want other manufacturers right around you, economies of scale in terms of transportation. The only thing that's a problem there is if you've got a scarce labor force and you start, artificially driving wages up. But for everything else, manufacturers, it's almost ideal. Well, it is ideal to be located next to each other, and they will tend to cluster. So anyway, those same slides on location. Integration. For some reason, people get this concept confused, but it's not that difficult. Just think about where you're at and what the next step is. In this case, it's a fried chicken chain that wants to acquire mills and poultry farms. Well, where are they at? They're down at the retail level, and they're going backward up in the supply chain, so backward integration. If it was the farm trying to sell stuff to retail, then that'd be forward integration. Horizontal integration, we don't deal with that here. Current transformation is, that's taking the chicken and turning it into fried chicken. That's a transformation. And job expansion is not relevant. So all those pictures we just talked about, again, it's integration is usually done by successful companies, but sometimes it can be the end of their success, because they may find they were really good at one particular process, and now they kind of step out of their comfort zone, or they start stepping on the toes of their suppliers or their retail outlets. So again, not something you just jump into, and because of that, it's a bit more risk. Current Forward, backwards, everything we just said. Yeah, so risky in the industry's rapid technological change. It's risky in any type of endeavor because really, you've got a proven track record. You're in a point where you can expand, and that means you're probably pretty good at what you're doing, and now you're jumping into sort of new territory. So yield management, a hotel room that goes unrented, airline seat that goes unsold, perishable inventory and services. So again, you don't. The key to yield management is that you don't affect your current customer base. That's why the advent of selling things online and kind of discreetly is much better. It doesn't work well when people know what everybody else is paying. So, but the other characteristics you need for yield management, just think of an airline type thing. Sold in advance in consumption. Obviously, demand fluctuates, depends on the seasons, holidays, things like that. Capacity, going back to an airplane, ACE, fixed number of seats, and demand can be segmented. What they're saying there, tourists, business travelers, all kinds of different people, more than willing to pay different prices. And, they may not be excited about it, but they may not even know about it, but they in terms of the customer, their perception of it, that's fair. If I show up last minute, I'm going to pay a bundle. If I am buying 3 months out, I ought to get a pretty good deal. But this ties back into forecasting, because if your forecasts are off, you're going to have problems. An airline needs to know what the holiday demand, whatever, as soon as they start selling tickets, which is, 6 months, a year out, they need to know what that demand is going to be for that particular weekend. So, does Christmas fall on a weekday? How does that affect things? Does, Valentine's Day fall on whatever? They need to know so that they can set their prices accordingly. Variable costs are low, fixed costs are high. So the difference there is that, when the variable costs are low, back to the hotel example, does it cost the hotel any more to put another person in the room, or even more so with an airline? Does it cost any more to put another passenger on board? Alrighty then, we can do this. Which choice best describes a counter-seasonal demand option? So we've seen this a number of times. This is the whole, sort of the snow machine versus the jet ski, and it's developing a product mix. So whether you've got things like, snow machines, well, we just talked about, but how about snow removal versus, dirt work in the summer? If you've got that kind of mix, it's going to smooth out your labor. It's going to smooth out everything. So in a factory setting, obviously level of production is the most efficient. So if you can keep your personnel and your machine, utilization level, that is going to be the most efficient system. So here they go. That same picture. All right. Yield management. Again, capacity allocation to different classes of customers in order to maximize profits. So that's really it. Just like the example we talked about, where you could sell all your tickets for $300, but you will sell a lot more if say the average ticket price was going to be $300. If you sold a whole bunch for $100 and a whole bunch for $600. And obviously, though, that's where that forecasting comes in. If you sell a whole bunch of tickets, all your capacity at $100, and then you have all these people standing there at the last minute willing to pay $600, you screwed up. So anyway, one example. So hotels, airlines, rental cars, yeah, those have already been adapted with yield management, and the other ones are coming along. Other theaters, restaurants, they will try to do this at some point, but it's tougher to implement. Now we got a puppy. All right. Which portion of the master production schedule is normally fixed for us? So this concept of time fences, system nervousness, what happens is, you want to be very flexible in terms of production to a certain extent. If you start making changes at the last minute, you got some real problems. It's, personnel levels, we're working overtime, we're cutting back shifts, any of that at the last minute is not gonna work well. And the same's true with machine utilization. It's better at a certain point, let's say a week, 10 days out, this is the production schedule. Any other changes, we'll catch up at another time, and that will minimize problems and defects and everything else. Right in there, those whatever third and fourth bullet, system nervousness and time fences are the concepts we're trying to capture there. Benefits of affecting scheduling. Yep. So again, not a great question, but it does lead back to the scheduling bit, and that's why this is one of the ones on the sample and not on the actual test. But do know that bit about time fences and system nervousness. Variability in manufacturing. So what is variability? Variability is anything that, well, it's basically waste. It's products that are also as a defect. So waste and variability and defects are all kind of the same thing. And variability can be just like it says in here, that the drawings aren't complete, or that the customer's wishes aren't known. So you're making products that may conform to what an engineer thought people wanted, but in terms of what the customer wanted, they're actually comprise a defect. So, but yeah, if you don't have clear instructions, the machine operator, the programmer who's programming the machine is going to not put out the products you want. How do you remove variability? So anyway, variability, any deviation from the optimum process, and it's defined by who? By the customer, right? If you got a bunch of inventory, though, that's why just-in-time is kind of a big concept in this test and quality in general, because if you've got huge amounts of inventory, you can't do continuous improvement. You've got defects possibly. You got all kinds of problems. And that last bullet, variability and waste, they're pretty much directly related. Sources of variability. So we already had the inaccurate drawing, the unknown customer demand. So that's really in the the high level quality type stuff where, yeah, it may be perfect in terms of what the engineer drew out, but if the engineer was out of sync with what the customer wanted, then it's worthless. It's a defect. So poor production processes, yeah, that's pretty identifiable as a defect in the traditional sense. Waste is anything that does not add value. So again, this concept too, there's value stream mapping. Remember that, where everything that's done to a product, you identify it. If it can't be translated to a tangible benefit for the customer, then it's waste. Eliminate waste. Customer point of view. And inspection, delays, queues, transportation type stuff. Anything that's doesn't equate to value in terms of the customer is waste. Just-in-time partnerships. Yep, small lots. So again, factories are going to be built a little bit smaller in terms of the actual space, so that there's fewer steps. Because again, stepping from one machine to another, moving stuff around, long distances, that's wasteful. So, materials arrive when needed. Drives out waste, and the whole buyer supplier. Again, if you're ordering from multiple vendors and you got all these different products showing up, but they all have to be inspected, because you've got to assure that you've got, a high level of quality, low amount of defects, like Six Sigma type stuff, 3.4 defects per million. In order to do that, and if you had a bunch of vendors, you're going to waste a whole lot of time doing inspection. So that is waste. So fewer vendors, better working relationship, more trust, the rest of that. Also, if you have trust, then you can allow the vendors higher up in the chain to actually see some of your forecast data and other things. They may be a vendor that sells to your competitors. So again, you have to have some sort of trust. A lot of times the way they'll work around that is they'll have like a local representative for the vendor, hopefully on site if it's like a car factory, like a Toyota plant. And they may have certain limits on what they can communicate back to their main office, so that proprietary data, Toyota's forecast doesn't get out. So anyway, difficult to work out, but well worth it. Just in time, carry inventory just in case something goes wrong. No. Inventory is a crutch. When people have inventory, a company has inventory, they may kind of waffle along and be, just kind of inefficient, and it's hard to identify what's going wrong. But that's because their inventory is masking a lot of those problems. And so that is not a good reason to have inventory. Competitive advantage of just in time. So I think we talked about most of these. Few vendors, small lot sizes, zero deviation, statistical process control, empowered employees. The employees are also going to do all that continuous improvement, and also, we'll talk more about that maintenance reliability. They're kind of your first line to ensure capacity. First step in reducing setup times is to the separation of setup prior. So yeah, this is true. The way this works is, especially if you're using modern machinery that's software controlled. Obviously, the software for the new iteration for the next model is written the day the old software is launched. So whenever the mod is different enough, better, you go ahead and introduce it. So even the notion of model years, there used to be distinct, and a lot of the examples go back to cars, but there used to be distinct model year changes that it did not happen. You still see that in styling, but you will see sort of mid-year changes when they find there's a better way to do something, some sort of continuous improvement. The change process is much easier to get that done. Reducing setup times. This is their graphic for that, but anyway, the deal is, reduce those as much as possible, and it has to do with evaluating the process and find out what's causing the excessive setup times. Just-in-time layout tactics, little inventory space, poka-yoke. Remember that poka-yoke are things that only go together one way. If you've got a problem with parts being assembled incorrectly, is it really the assembly guy's fault, or is it the designer who sets you up kind of for failure? Everybody has a bad day now and then. If there's simple things you can do in the design phase to make things basically only go together one way, the correct way, then you've helped everybody out. Space, inventory, yep. Small lots, units are always moving because there's no storage. So very dynamic. Stuff's not just sitting around. Inventory is kept at the minimum level. So the concept of this pull system, again, kind of like a grocery store where, they don't come set a box in the aisle. No, you take one can of whatever, they put back another can, and they put it right there, pretty much just in time. Usually overnight, but whatever. It's the same sort of thing in a factory. It would work perfectly. Which of the following is generally found in most just-in-time environments? So, pull systems, right? Push system means that you're just kind of blindly shoving stuff out to the floor, hoping that it's going to be used. And also, if you're using that throughout the program, the customer doesn't really get a vote until the end. I mean, the way it should work in a pull system is the customer sends a demand signal, a Kanban, if you will, some sort of card type order, and from there on out, it goes up the cycle, and that demand signal eventually ends up with the product he asked for being produced. So quality, yep. Like we say, you need just-in-time to do quality. If you're getting kind of the feeling that there's a lot of just-in-time on the test, you are correct. If the goals of just-in-times are met, which of the following result? In-transit inventory falls as suppliers are located closer to facilities. So again, you see this in reality, Again, I end up going on the south quite a bit. But anyway, if you drive down that corridor, I-65, I-85, anyway, you see a few auto plants, and right around them you see all these auto parts suppliers. So rather than ship stuff cross-country, it's much more efficient to ship it across the plant. Statistical process control, you're familiar with that. We've seen this slide before. Characteristics of just-in-time do not include large lot size. If you've got, if you're saying you need to do large lot sizes to cut down on the setup costs, what you need to do is you need to cut down on the setup costs. A lot of those things can be, especially in the ordering process, that's much easier to do now, where you have some sort of blanket order, and you also have paperless ordering and the rest of that. So it's plus when you have just a few vendors, this whole bid process can be almost eliminated. You hurl a lot when you're in trouble. Reduction of in-transit inventory can be encouraged through the use of supplier location near plants. So won't do that question again. The whole notion of the rocks, in terms of inventory, like we say, if you've got a factory that's got tremendous amounts of inventory, it will conceal a lot of the problems of that factory, because you won't actually identify the underlying problems because you've got so much inventory around that it's acting as a crutch. Which of the following statements is true regarding just-in-time? Minimum inventory to keep the system running. So, no large lot productions. Exist just in case something goes wrong. No. You need to be able to identify and also have an agile enough supply chain to compensate for screw-ups in forecasting. If you get your order quantities wrong, but you have the suppliers right close by, you can compensate and overcome that situation pretty quickly. Better scheduling improves performance. So freezing part of the schedule, eliminates waste, small lots. So it all relates back. All this quality stuff. It's not that I'm showing the same slides over and over again. It's all the same concepts. It's all quality. Which of the following is not an attribute of lean operations? So lean operations, if you want to go there, it's lean is just sort of the bigger aspects, the enterprise level of manufacturing. So you've got just in time down at sort of the tactical level, and then lean is up at the higher level typically. But it's the same concept, so don't get too wrapped up about it. Pushing responsibility to the highest level through centralized decision making is not a good idea. It doesn't work for anything actually, but especially in manufacturing. All right, we've got every dog now. Anyway, no centralized decision making. You've got empowered employees. You're trying to delegate responsibility downward and keep things in touch. So, building a lean organization, develop employees, make jobs challenging, build worker flexibility. The manufacturer took the following actions to reduce inventory. Which of these is generally not accepted as just-in-time action? Okay, supplier that offered the lowest price based on quantity discounts. Again, it's usually, why is this quantity discount happening? A lot of times it may be obsolete products. Okay, enough. And again, a lot of times it's kind of a false economy. When you pay to store, if you finance this stuff, if you have pilferage coming on, shrinkage, it's not going to be as cheap as you think. So you're better off sticking with smaller lots and moving on. Product failure rate is a percentage of failures among the total number of products tested. True. What we're really talking more about is that concept down at the bottom, mean time between failures, because that's the number that's pretty useful. Again, the example, hard drives, that's pretty much figured out now that people who work with hard drives in terms of storage that needs to be maintained, they know to look at numbers like that to see what the forecast, sort of life expectancy of certain mechanical things are, and to make sure that not all of their inventory, not all of their items that they have doing this memory storage are going to fail at the same time. So, but same is true with any kind of machinery that you have. If it's got a mean time between failure, there's something that's something you want to track. Preventive maintenance is reactive, false. So breakdown maintenance is, it's running, it breaks, we go out there. But preventive maintenance is usually based on time intervals, where you get out there and, it's 30,000 miles, something needs to be done, so many hours on a machine, it needs to be oiled, it needs to be greased, it needs to be rebuilt. So that's preventive maintenance. So breakdown, preventive, and predictive. Again, predictive is, if I want to say best, but breakdown has its applications. I mean, light bulbs, stuff like that. That's how you do it, or machinery that's has some redundancy applied and doesn't really require maintenance, and just let it go till it stops. Preventive maintenance, again, mechanical things that their life can be extended by regular changes, and you don't necessarily see the indications that things are wearing out, but you just know based upon engineering data that it needs to be done at a certain point. And then predictive maintenance is again, I'll say it the best, because it's what predictive maintenance, it gets back to the reason for maintenance, and that's to ensure reliability, to ensure capacity. So when you set up a factory to produce a certain number of items, predictive maintenance will allow you to have that high reliability, because you're going to be able to know you should not have any untimed mechanical failures, because like I say, any mechanical item or electrical item or whatever, they usually don't just spontaneously fail. There's usually some sort of degradation, whether it be vibration, heat, noise, something like that. If you've got the correct sensors on there and you're paying attention, you'll be able to almost eliminate breakdowns. So anyway, infant mortality. So yeah, a lot of items will fail right from the get-go. Either it's small components or engineering problems, but anyway, if something works for say an hour, it's probably going to go out to its whole mean time between failure. But at that first, when it's first plugged in, first turned on, first fired up, there is a high failure rate. And if at all possible, if you're dealing with those kind of items, it's much better to have that done in the factory before you ship it to a customer who now is a little frustrated and causes a whole ripple with things going the wrong way in the supply chain. Preventive maintenance. So yeah, it's based upon good engineering data. Infant mortality is mentioned in there. MTBF, mean time between failures. Yeah, and it's all based upon records. Product failure rate, MTBF, breakdown cost models. Again, it's even better to be done with continuous monitoring and predictive maintenance. Problems with breakdown maintenance. Again, good for low criticality, redundant systems. Yeah, you can't use it in things like aircraft or even vehicles to a certain extent. Fix it whether or not it's broken. Yeah, if sometimes you may be in a situation, say like in engine oil, if the engine motor is run under very controlled conditions and at constant speed, the oil might go for quite a bit longer than something that, a hot, dusty environment. So again, if that's not really addressed in part of your program, then you may be, needlessly, throwing away good parts, good oil, good whatever. So, and it also can be misapplied where people break stuff actually in the inspection process. Predictive maintenance. So we've kind of beat this one to death. A lot of technology involved, though, and a lot of opportunities, and then a lot of data that comes streaming from this continuous monitoring that can be applied to other management type decisions. Yep, avoiding the cost. So again, when you get into reliability, if you get highly reliable parts and then you monitor them, you get to the point where you should not encounter failures, and you should be able to accurately forecast that capacity, in terms of the reliability of the parts. Vibration analysis. Yep. Everything's going to fail a different way, and that monitoring service, it's a win-win. You get somebody else to take care of monitoring the problems, but they also have an inroads now when parts break. They're going to be the ones showing up, telling you what's broken and have the parts in hand, so it works for them as well. The objective maintenance reliability, it's going to be something about capability. Yeah, capability, capacity, D there. So breakdowns will still occur. Yeah, breakdowns do not affect. Ensure maintenance employees are fully utilized. Anyway, yeah, D is the correct answer. So these two terms, very much related, obviously. Maintenance are the activities to keep the machinery going, and reliability is that probability that you're going to get that capacity, that capability you purchased. Reliability, so the individual components, and then maintenance, increasing repair capability. When we get in reliability, you're going to have all those different problems, whether it's in series, whether it's in parallel. Make sure you're keen on that. We'll talk about that in a second. Which of the following best illustrates the importance of employee involvement, maintenance reliability? Rewards, systems, power sharing. Anyway, the big deal here is what you see more often than not is inadvertently, incentivizing people to break machinery. Not to say that all these guys are evil, but sometimes, if everybody gets a break every time the machine breaks, you're setting yourself up for failure. If you can get the employee, to kind of take some ownership for it and do this frontline failure, then in essence they're doing continuous monitoring, and they're also doing the preventive maintenance and the rest of it. So, good idea. So these are those reliability problems I was talking about. This one is in series, right? So obviously when you multiply numbers less than 1 together, they get less. So, 95, 85, 99. Wow, that ought to be somewhere around 90. No, less than 80% because of the multiplicative effect. There's an example. And here's an example of how it works when you've got items in parallel. So it actually goes better. So, you have one part that's 80% reliable. You put a second part next to it that's 80% reliable too. But they're in parallel, so if either one works, you've got a success at the end. So it's going to be something more, and that something more is you get that 1 minus the 0.8, gives you 0.2. Anyway, multiply that across, 0.16. So anyway, you're up to 96%, which is a good thing. All right. So not too much else on the test. You'll have 90 minutes to get it done. Again, if somebody has an issue, I can probably extend that time out. But with 50 questions, multiple choice, true, false, you won't need to know any formulas per se. I mean, you can do the math on the redundancy type problems, and a little about MTBF type stuff, mean time between failures. So not too much else. Again, so I anticipate, sounds like about maybe half the class probably taking the test Wednesday after class, so that'll be fine. And what that'll mean is that the rest of you can take it basically whenever you want, because there's not going to be that many more folks. So the next time will actually be a week later, that Wednesday in the personal finance class. Then there's one on Thursday, I believe, and then a couple on Friday. Anyway, you've got it in the announcements section. You'll bring your homework, obviously, and that's pretty much it. The test is already up on Blackboard. I've already gone through it once or twice to make sure the questions are how they should be. But on the written test, I'll probably have an answer sheet as well as the test, just to try and speed up that process for you guys to get the answers back. your final test questions back. If you have any problems, let me know, and I'll post this. This is Sunday, so I should have this. Well, I'll get this out today, and so you'll have at least 4 days or so to look at this in case you care to take the test right now. Not right now, but you know what I mean.